Today we talk about the impressive Boeing Recoverable launch booster. Is it real? Stay until the end. Like, share, and subscribe. Welcome aboard and fasten your seatbelt for landing. In the early 2000s, Boeing dared to dream of a revolutionary leap in space access. Thus emerged the concept of the Boeing Recoverable Launch Booster, ROB, a visionary project that combined the power of a rocket with the reusability of an aircraft. The idea was simple yet bold: to build a reusable first stage with wings, jet engines, and landing gear, a true hybrid between an aircraft and an orbital launcher. During launch, the ROB would act as the initial booster, lifting the payload from the second stage to critical altitudes. Then it would detach, flip midair, and glide back to a standard runway like a conventional plane. The aim was to cut costs and increase launch frequency. Despite promising designs and advanced studies, the project never left the drawing board. Technical and budgetary challenges, along with the rise of new competitors like SpaceX, placed the ROB on the shelf of what-ifs. Still, its legacy endures as inspiration for aerospace engineers who today make real what was once only a bold sketch on Boeing's drafting table. The ROB wasn't born in a vacuum. For decades, the aerospace industry has sought ways to make spaceflight more accessible, reliable, and, above all, economical. Since the dawn of the space race, expendable launchers have posed a significant problem. After launch, millions of dollars in equipment literally fell into the ocean. In this context, Boeing, a giant in both aviation and space systems, decided to bet on something different. The project was born from the Future Space Transportation System program, backed by government research centers. The goal was to develop a partially reusable launch system, leveraging Boeing's vast experience in both rocket construction and sophisticated aircraft design. The ROB would become a true crossbreed, part jet, part booster. Its appearance was striking. It looked like a muscular aircraft, with a wide body, strong wings, and rocket engines mounted at the rear. At liftoff, it functioned as the first stage of a traditional launcher, accelerating the payload to about 100 kilometers in altitude at subsonic speed. After stage separation, it would perform a control maneuver, re-enter the atmosphere, activate integrated jet engines, and fly back to a designated airfield, landing like a regular plane. This maneuverability was a key advantage, unlike rockets that fall into the sea or land vertically using retrothrusters, like SpaceX's Falcon 9. The ROB didn't require complex recovery infrastructure. All it needed was a runway. The goal was clear: drastically reduce launch costs by enabling rapid reuse and minimal downtime between missions. In the early development years, Boeing engineers conducted advanced simulations, built scale models, and performed wind tunnel tests. The program excited investors and researchers. The U.S. Department of Defense saw the system as a potential asset for launching observation or communication satellites into low Earth orbit. But the early excitement gave way to mounting challenges. The biggest was weight. To carry onboard flight systems, engines, landing gear, and return fuel, the ROB had to be significantly heavier than a traditional first stage. That undermined the mission's overall efficiency. Every additional pound in the first stage meant one less pound of payload in orbit. Additionally, the integrated systems demanded specialized maintenance, complicating the quick reuse goal. Another problem was thermal control during re-entry. Even without reaching orbital velocities, the ROB would face intense heating when descending through the atmosphere. It required a fuselage that was both lightweight and durable, capable of withstanding multiple re-entries without the need for major material replacement. Boeing explored advanced composites and heat-resistant metal alloys, but the cost soared. Meanwhile, the global space industry was shifting. Emerging companies like SpaceX began to offer bold, surprisingly effective solutions. Instead of wings and jet engines, SpaceX bet on vertical landings using rocket engines. This approach, though complex, allowed for stage recovery with less structural weight. In 2015, the Falcon 9's successful landing revolutionized the industry, casting doubt on the feasibility of designs like the ROB. Still, Boeing didn't abandon the concept overnight. The project was reimagined several times. Slimmed-down versions emerged. some with retractable wings, others using parachute-assisted landings with auxiliary jets. Partnerships with space agencies were explored. Rumors even swirled about classified prototypes being tested at military facilities, though never officially confirmed. But the core issue remained: cost versus benefit. Gradually, the RLB's math stopped making sense. As competing technologies advanced, and with federal budget cuts and private companies dominating the field, the RLB program was quietly shelved. By the late 2010s, the Boeing Recoverable launch booster had become a promising idea with no clear place in a rapidly evolving market. Yet, its legacy didn't vanish. Much of the technical knowledge gained during its development fed into other programs. Studies on hybrid structures, re-entry control systems, and reusable components influenced both civilian and military initiatives. The concept of reusability was no longer a novelty. It had become the new standard. Today, engineers and technology historians look at the ROB as a symbol of transition. It represents the moment the aerospace industry began moving away from reliance solely on large government agencies and started embracing fast, disruptive innovation from private companies. It also represents the enduring dream of making spaceflight routine and accessible. In a world where satellites are launched weekly, tourist orbiters, and rockets land with pinpoint precision, the RLB stands as a reminder of a road not taken, yet one that inspired much of what followed. It is proof that even unrealized projects can propel imagination and progress. If today we speak of reusable rockets as a given, we owe that too to concepts like the ROB, which, even without flying, helped chart the course to the stars.